Hi, welcome back, my wonderful kiddos. We're talking about chemical reactions right now at Allen High School at the APIBHL level. And we want to move into some examples of Sngl replacement reactions. So let's take a look at that. I've got the framework set up for you in your notes. I'm going to go through these fairly quickly, and hopefully you will write down or mark, highlight your questions, so as soon as you come in, we can have a good conversation of those. Now, the first one says that I have magnesium shavings. So I have magnesium. Those shavings indicate it's a solid, are added to a solution of iron 2 chloride. So that's FeCl2. I'm presuming you can write chemical formulas by now. Solution of means aqueous. Now, when magnesium goes into a compound, it wants to become magnesium plus 2. So the question is it going to dance with the plus 2 iron or the minus 1 chloride? Well, cations always dance with anions. So I will get magnesium chloride plus solid iron. Now, solid iron means that it has a 0 oxidation number. Be really careful. Some of you will be tempted to keep that plus 2 oxidation. This is a redox. The plus 2 goes to 0. So it's plus 2 in the compound, but since it's a redox, it's going to gain 2 electrons. Now, magnesium chloride is soluble. And magnesium, you would be given some indicator that that's soluble because you don't have to memorize those solubility rules for that. So the question would give you an indicator. I'm going to keep those as solids. Now, there are 2 species on the reactant side, but one of them is an element. That's how you know it's a that's how you know it's a single replacement, not a double replacement. So magnesium, the chloride becomes a spectator ion, and magnesium goes from 0 to plus 2. It is oxidized because it lost electrons. The iron becomes iron 0 because it was reduced. It gained electrons. Now, since the magnesium wanted to be the cation, the metal that prefers to be the cation is the most active. So magnesium's the most active of these two. Let's take a look at this one. We have sodium. Now, I like to write water in reactions as HOH. Right? When sodium is dropped into water, you can think about water. You don't want to write it this way. You can't dissociate water, but you can think of it as an H plus with an OH minus. So sodium, when it goes into a compound, right now it's 0. When it goes into a compound, group 1 wants to be plus 1. So the sodium, positive cation, cations dance with anions. Now, remember, single replacement, one substance is going to be left all by itself. But hydrogen is diatomic, so don't forget that. All right, so I have sodium element. Never dissociate your water in these reactions. All group 1s are soluble, plus sodium hydroxide is a strong base. And then I'd have hydrogen gas. And I don't have any spectator ions in this case, so there are none. And my complete ionic is the same as my net ionic. So let's go on to the next group. Let me erase the board here. Let's go on to our next category. That was with water. Let's look at an active metal plus acid. And this is an example of the reaction that we saw earlier that we were predicting activity based on it. So we have mossy zinc. You've seen mossy zinc. You'll see it more. If it's pure zinc, it's a solid, oxidation number of 0. If I add that to hydrochloric acid, aqueous, acids are aqueous, the H is positive, the Cl is negative. Zinc, remember, is part of that staircase, which means that when zinc goes into a compound, it wants to be zinc plus 2. Cations dance with anions. So I'd have zinc chloride. Hydrogen would be by itself, but as a diatomic. And then we would need to balance that. So I'd have zinc solid. Since this is a strong acid, I'd have 2H plus 2Cl minus. The question would give you some indicator that this was aqueous. Our indication of a chemical reaction is the formation of a gas. The question would give you an indicator here because you don't have to memorize quite all those solubility rules. So it is soluble, so zinc plus 2 and 2 chlorides, and then hydrogen gas. And we see then that chloride is identical. It's got to be the same state. Here I've got zinc 0 solid, zinc 2 plus. That doesn't cancel. Only the zinc chloride, because it's in the exact same form as it was above, cancels. The zinc is not in the same form. It's a solid here, but it's a dissolved ion as a product. So that would be my net ionic reaction. Let's do one more. We've got chlorine gas. Don't forget your diatomics. Bubbled through a solution of chromium 2 iodide, excuse me. Okay, remember, this is going to have a color associated with it. Okay, a color. And I'm just assuming that it's a saturated solution. Okay, so that I'll be able to break these into ions. Right? And I will get chromium this time. Right, this is 0, this is plus 2, this is minus 1. All right. Now, when chlorine goes into an ionic compound, it wants to be chloride. Anions dance with cations. So the chloride is going to go with the chromium, and that leaves iodine. Iodine is purple, so you would see that characteristic color there. Okay. And if I dissociated this, I'm going to get Cl2 plus Cr2 plus 2 iodides. Go to Cr2 plus. Absent of any more information, I'm going to make the assumption that's aqueous for you. Cl minus plus I2. Right? Now, this time, the anions stick around, and it's the cation that was the spectator ion. So we've got Cl2 plus 2I minus is going to go to 2Cl minus plus I2. And our chromium there. Now, remember when metals, the more active a metal is, the more it wants to be a cation. For a non-metal, non-metals want to become an anion. Non-metals in a situation like this want to be reduced. So since the chlorine preferred to be reduced above the iodine, that means that chlorine is more active than iodine. And in fact, it goes according to the periodic table. Fluorine is more active than chlorine, is more active than bromine, is more active than iodine. More active means they prefer to be an ion over the pure element, oxidation number of 0. All right, that's it for Sngl replacement. This took a little bit longer than the others because of having to learn activity. Some of the others are going to be very quick. So, you know me by now. My definition of quick is not the same as yours. So until then, this is signing off.